Assalamu alaikum dear students. This is AS Physics 9702, chapter number 5, Work, Energy and Power. Today this is the first lecture of this chapter and the topic is work. How you will define work is very simple, and the product of force and the displacement in the direction of the force is called work. Then you can write the equation for the term any work in this way, like if F is the force and the displacement is S or D, then we can write the following equation for work. How you can write? Simple thing is that work is equal to force into displacement. Here I use a dot here and I will explain the meaning of this dot as well. So this is work done, and here you can write W or work as F dot D. But remember this thing that when you will write this way, these two, force and displacements, both are vector quantities. But as far as the magnitude of the work is concerned, how you will calculate this thing, so this is important. Here, what we are saying that if we have a block, suppose, and on this block we have a force F, and this block is displaced by distance D or S, then what you can write simply as we have mentioned that this may be D or S. So what we can write here, the simple displacement is in the direction of the force, but you have or you may have another situation where the force is not acting in the direction of the displacement, but suppose you have a situation like this. You have a wheel and you are applying a force somewhere here, then the force is making an angle theta with the displacement. So this time what you have to do, you have to consider the component of the force which is in the direction of the displacement. So where is this component? So what you can do, first of all, you are resolving the force into two components. One is Fx, the other component is Fy. But as you can see here that Fx is the component which is in the direction of the displacement. So what you have to do to get the magnitude of work, you have to consider Fx only, yani the component of the force which is in the direction of displacement, and this displacement S or D. Then you also know, I'm writing here as, but as Fx is equal to F cos theta. Therefore, what you can write for work, F cos theta into S. So this will give you the magnitude of the work done. Here, F as cos theta you can write for work, and as I said that the situation of this equation is that you are getting the magnitude of the work by using this equation. Suppose this is equation 1. So this is very important, that what we have to do, the component of the force which is in the direction of displacement will be our concern, or simply we can write that work will be equal to, or magnitude of the work will be equal to, force times displacement times cos of theta. So this is what we have. Now we have that if theta is equal to 0, then simple thing is work is equal to F cos S, cos theta S, or simply Fs cos theta. So what you are getting, as theta is equal to 0, so Fs cos 0, or simply you can say that this is nothing but F into S. So you can say that this will be the maximum work done, but if the angle is different, like if theta is equal to say 45 degree, then what will happen? So again you will use the same equation, work is equal to Fs cos theta, or Fs cos 45, as cos 45 is 0.707. So simply you can say that this time work is nothing but this value, Fs. And of course, whatever the value of F and S, but you know that it is less than the actual value or the maximum value, which is Fs. So this is something which is very important to note, that when the angle will increase, like suppose here you have a situation that you are considering here angle of 60 degree, then what will happen? Simply you can say that work will be equal to Fs cos of theta, or Fs cos of 60 degree, but as cos of 60 degree is 0.5, so simply you can say that this time work will be equal to 0.5 Fs. So you can say and see that the work is decreasing when the angle is increasing, and at one point, like suppose you have a situation of angle theta is equal to 90 degree, then what will be the situation of the work? Work is again Fs cos theta, this time Fs cos 90 degree. So what you can say that Fs into cos 90 is equal to 0, so no work, 0 work, or we can say minimum work. So remember this thing, that when we are considering work, force must be in the direction of displacement to get the maximum work done. But if the force will be perpendicular to the displacement, like this suppose, then what will happen? As we have just mentioned, that if the displacement is in this direction and the force is in this direction, any perpendicular force, then there will be no work done. Now, how it is possible that the displacement is in this direction and the force is in the direction which is making an angle of 90 degree? So simply you can say that if you are holding, you are moving, and you are holding a block or a body or a ball, suppose, your displacement is here, but Remember this point that the force which you are applying or your hands are applying is in this direction. So simply you can say your hands are not doing any work. Be careful. You can say that I am doing some work because I am moving and my hands are of course the part of my body. So overall situation is that I am doing some work. But as far as the hands of the person is concerned, hands are not doing any work because the force is acting perpendicular to the direction of the displacement. So remember this thing that this is the situation of the work. Just to show you this situation, I'm going here, and you can see here that we have a force and we have a displacement. We can change this displacement, we can change the force as well. For the time being, the solution of this particular thing is that work done is equal to F cos theta S. So if you have 1.8 and of course the angle is 19.2, which is close to 90, zero point 0.1 is the displacement, so the work done is 0. And if you are moving the body in this direction, what is happening? No work is being done by the force. So remember this thing that unless the force will be in the direction of the displacement, so you can say that when the force is in the direction of the displacement close to 0, the 0.3 cos 0.3, or you can make it more close to 0. So you will see that what is happening, you are getting the maximum value. So 2.2 meter is the displacement and 2.3 is Newton is the force. So what you are getting, 5 joules, which is the unit of the work done. Displacement is in meter, Newton is the unit of force. So ultimately what you are getting, work done, which is 5 joules. So if you will increase the force, of course, you can say that now you are doing more work, and the thing is that of course the displacement will also be more than before. Then you can say that the work done is now 26.3. But again the same thing, if you are making an angle somewhere here, then you can see that the component of the force which is in the direction of the displacement has decreased. So what is happening? You can say that now the displacement is fine, but we have the value which is only 17.2. Yani work done is only 17.2 if we are using the same force. And if you will decrease the angle, then you can say and see that the work done will be more and more. So when you will have the force exactly in the direction of the displacement, then you can say that you will have the maximum work done. But when you will increase the angle, somewhere here you are, so you can say and see that what is happening, the value is decreasing. So this is very important to understand that what will be the situation of the force and its component. And when you will change the component, yani when you are changing the angle, the value of the force will be, you can say, more and more. But if for the same value of 3.4, suppose you have a situation like this, so what you can say that what is happening, the work done is becoming 0. So this is very important to understand that how we can change the value of the work done by changing the force or by changing the direction of the force. So this is very, very important. You can see here that when you are going towards 90-degree, the value of your work done is becoming 0, and when you are decreasing the angle towards 0, you are getting the maximum work done. So this is something which is important. Now we have to consider one thing, that the force is a vector quantity and displacement is also a vector quantity but work done is a scalar quantity. So remember this thing, that when we are dealing with this situation, that we have two vectors and the product of these two vectors is nothing but a scalar quantity like this, then we will use a dot in between these two things or these two vectors f and d. So that's why we have used this dot in the beginning of the discussion. So this is one thing. The second thing which we have to consider is nothing but the situation of unit, or what will be the unit of work. So again the same thing, it's very simple. The unit of force, or SI unit you can say, of force is Newton. You can write in this way. And the unit of displacement is nothing but meter. So you can simply write the unit of work is nothing but the product of these two things, yani Newton and meter. And Newton meter is termed as joule. So remember this thing, that if you are writing the unit in terms of Newton meter is okay, or you can write joule for the unit of work. So this is very, very important. And then of course you can go to the other topic, which is power. And when you will consider the power, here you will have the situation like I can add here the power is nothing but, how you will define the definition of power is simple, and this is the rate of doing work. The rate of doing work. So what is rate of doing work? So simply you can cite that equation of power, we can write in this way, that power is nothing but work done per unit time. You know that if you have a displacement S, suppose, and the force is F, then work done is nothing but F into S. And if this work is done in time T, then this will be the situation Fs divided by T. But as S over T is nothing but displacement over time, which is velocity of the body, and we have been using V for the velocity. Thus, we can write power as power is equal to F into V. Then what actually we have done? We have replaced this S by T by V. So this is what we have. It means that you can also use this equation for power when you are considering force and velocity. And of course, the basic equation is nothing but this equation, yani work done per unit time. So these are two possible equations for work done. Now, as far as the unit is concerned, we have the unit of power and unit of work. Unit of work is nothing but unit of force multiplied by unit of displacement. Unit of force is Newton, and unit of displacement is meter. Or in base units, you can write kg meter per second square for Newton, and of course meter is here. So as far as the work done is concerned, it is kg meter square per second square, which is again we can write the work done is joule. So this is something which is very important to understand, that if you want to write the unit of work, you can write joule, or in base units you can write kg meter square per second square. On the other hand, if you want to write the unit of power, then again you will use the equation, which is the basic equation for or definition of the power, unit of work done per unit time, yani unit of time. So unit of work done here you have, and of course unit of time is second. So kg meter square per second square divided by second. So what you are getting, kg meter square second power minus 3, or per second cube. So this is what we have as far as the unit of power is concerned. So I hope that you have understood these things, very simple definitions and their units and their equations. So inshallah we will be continue with this chapter. And if you are new on this channel, so subscribe this channel and press the bell icon so you can get the all new uploaded videos. And if you share and like this channel, of course the other students can also get the benefit of it, and we will be you can say motivated as well. So inshallah in the next lecture see you again. Till then, Allah Hafiz.